Yeah, maybe I did. Ugh. Okay, it's recording now. Okay, so so 2 to the square root of 30 over 3 to the square root of 30 is 2/3, but this one is not 2/3. So 2 to the square root of 30 minus 2 over 3 to the square root of 30 minus 3 does not equal 2/3. So I was right when I anticipated that. So in this particular case, it happened because these two top and bottom are the same and these two are the same. But it doesn't happen in this scenario because I have 1, 1 and 1, 2. So that messes up the ratio. But I cannot thank you enough for asking that, Derek. But is it clear?
Yeah, I understand. I didn't mean to, go off track so much.
Oh no, but it's a very good question. It's a very good question. It made me think. I mean, I felt that was the answer, but I just didn't want to say, you know what? I think that's it. I wanted to use an example and show you that, and also convince myself that I was correct. And that is quite all right. Okay, so let's continue with something else. So now we know the poster problem by heart. That's fine. Okay. Let's look at number 10. The rate in milligrams of carbon per cubic meters per hour at which photosynthesis takes place for a species of phytoplankton is modeled by this function. If I mispronounce that, forgive me. Where I is the light intensity measured in thousands of foot candles. For what light intensity is P a maximum? This is an easier situation because the function is given to us. We don't have to start from scratch to create the function. So let's do that. So this is problem 10 on page 332, and this is P equals 100I divided by I squared plus I plus 4. I is the light intensity, so I is measured in thousands of food candles. And P is measured in milligrams of carbon per cubic meters and per hour. So for what light intensity is P a maximum? Okay. Not a difficult situation, I would say. It looks difficult, but I wouldn't say it is. What are we asked to do? We're asked to find for what intensity is P maximum. There is a function of only one variable, and we know how to handle that. So what do we do? Yes, so we find the derivative. So leave the constant outside, this constant, because it's a factor. Leave it outside, and now differentiate the top, get 1. I squared plus I plus 4 minus I, the top, and in parentheses, we differentiate the denominator. When I differentiate the denominator, we get 2I plus 1. Any questions? Okay, so then I have to clean it up in the numerator as much as possible. So I squared plus I plus 4 minus 2I squared minus I over I squared plus I plus 4, everything squared. And let's see what we left. We are left with 100 negative I squared plus 4 over I squared plus I plus 4, everything squared. Yes, you know me, I'm going to factor out negative. And then I have it I squared minus 4, which is I plus 2, and I minus 2. This is quite nice. I will set it equal to 0. So P prime of I equal to 0. This can never be a 0. It has imaginary solution, so this is always positive, not 0. So there are two options, but I don't expect this to be an option, and it can be. So I equals 2. Thousands of foot candles. But I haven't convinced you of anything yet. So this is I, this is 2, and this is P prime of I. So when I plug in 0, I don't care about the denominator. So when I plug in 0, I get positive. Let's see what I get when I plug in 10. When I plug in 10, all this is positive. 10 minus 2 is 8, with minus in front is negative. So this is definitely a situation for a maximum. And we were asked to determine, and we showed why, and the answer is 2. Thousands of foot candles. Any questions on this problem? This was an easier situation. We didn't have to work our way through finding a function. We just used what we learned in this chapter. Okay, what about 19? I see it in red. Find the point on the line that is closest to the origin. Find the point on the line that is closest to the origin. Okay. Any questions before we continue? Any questions? Okay, so this was problem 19 on page 332. So the line is y equals 2x plus 3, and they want the closest to the origin. Find the point. Point closest to the origin. Okay. So I'm going to graph this line. Since it's a line, I need 2 points. When x is 0, y is 3. When x is 0, y is 3. When y is 0, x would be negative 3 halves. So negative 3 halves, comma, 0. I graph the function. Zero, 3. Negative 3 halves, 0. This is the line 2x plus 3. And they're asking us to determine the point on this line that is the closest to the origin. Well, obviously, the point that is closest to the origin would be this point, where the distance is the shortest, because this is the perpendicular to the line going through the origin. I'm not going to graph it, though. Here's why. I'm going to say this is the point. in order to find it. This point has coordinates x, comma, y. But y is this, 2x plus 3. So this is point P of coordinates x, comma, y. But y is 2x plus 3. I am going to draw this distance, this line segment. I'm going to create a function that represents the distance, and I am going to find the minimum of the distance. So, how do I find the distance between 2 points? Which points? 0, comma 0 and x, comma 2x plus 3. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So then I'm going to plug it in, and I get a distance, which is the square root, and it will be a function of x only. x2 minus x1 squared. Well, that's x squared plus y2 minus y1 squared. Okay. So let's do this one more time to make sure you are with me. So x2 minus x1, x2 minus x1 squared, y2 minus y1 squared. I will simplify as much as I can underneath the square root. And I have x squared plus, I know we know that a binomial squared has 3 terms. I have to present 3 terms. The first term squared plus 2 times the first times the second, 12x plus 9. I will combine like terms. Five x squared plus 12x and plus 9. It's completely cleaned up. So now I will find the derivative. 1 over 2 the square root 5x squared plus 12x plus 9, and I multiply by 10x plus 12 times the inner function prime. So nothing will be undefined, because if this is undefined, the function, it doesn't exist at that point. So what I'm interested in is to find the solutions to this equation. The numerator, or 10x equals negative 12, or x equals minus 6 over 5. I divide by 10, but I simplify by 2, and I get 6 over 5. So I know that point P has the x coordinate negative 6 over 5. I didn't mean to put that. And comma, I have to find the y coordinate. The y coordinate of P is 2x plus 3, for x being this. So 2 times negative 6/5 plus 3 to determine the y value of the point. So then negative 12 over 5 plus 3 over 1, if you want, times 5, because I have to find the least common denominator. So negative 12 plus 15, 3. And you can say, show me. You haven't proved, maybe this is the maximum distance. Maybe it's not the minimum. I have completely agree. I have to show that at negative 6 over 5, the function indeed is the minimum. So I'm going to have 0 here, and let's say negative 2 here. So when I plug in 0 in the derivative, this is always positive, I don't care for it. When I plug in 0, it's positive. And when I plug in negative 2, this is positive, I don't care for it, all positive. When I plug in negative 2, negative 20 plus 12, this is negative. So this is definitely guaranteed to be a minimum. So the point that is the closest to the origin is -6/5. It's hard for me to plot, but I don't need to plot. I know where it is. So I know the point is right here. It's not exact, of course. I'm going to say that this is the point and the distance is the shortest, which we knew, but we had to determine it. So this is -6/5, 3/5. Any questions here? Any questions? I'm sorry, I think there is a little piece of the lesson that I forgot to record. It's recording perfectly, so, because I deleted everything before. Almost everything, so. Any questions on this problem? Any questions, please? Anything? Anything? Would you like to continue with other problems? Would you like me to present Newton's method, which is the last section for the following test?
I think more examples.
Okay, very good. Very good. Okay, but any questions on the previous problem? Any questions on the previous one? I need more paper. Okay, so let's take a look at something else. Find the area, design. I'm also looking at the end of the chapter. For the review problems, sometimes more interesting problems are there. This is a interesting and not too difficult situation. Find two positive integers such that the sum of the first number and 4 times the second number is 1,000, and the product of the numbers is as large as possible. Okay, so let's try this, unless you have something else in mind. 15 on page 355. Find two positive integers such as the sum of the first number and 4 times the second number is 1,000, and the product of those numbers, which is x times y, is as large as possible. So we are told to find two positive integers that are in this relationship that is given to us, and we are asked to find those integers, positive integers, such that their product is maximum. I'm getting a sip of water. Okay. So obviously, like before, we have two variables in a function. I have to get rid of one of them. I will be using this equation to solve for y. How do I do that? I subtract x and I divide by 4. I replace y in the function, and now I can say that the function is a function of x alone, which is x times negative x over 4, plus 250. You could say, and I would have to agree, I don't need any calculus to do this problem. We do it in algebra. I agree. But let's see how we do it with calculus. I will have to distribute negative x squared over 4 plus 250x, because I know the vertex. I don't need calculus to find the maximum of such a function. But let's say we continue with p prime, and we get negative 2x over 4 and plus 250. Critical numbers, only when p prime equals 0. Nothing else is possible here. Then negative 2x over 4 plus 250 equals 0, or negative 2x equals negative 1000. I multiply both sides by 4, and I also moved 250 to the other side, so x equals 500. And this is one positive integer. The other positive integer, I replace x by 500 to find y. I have it right here. So it's negative 500 over 4 plus 250. So I simplify 250 over 2, 125. So y equals negative 125 plus 250, or y equals 125. So the numbers are 500 and 125. You can say that's fine, but you haven't proven anything. Well, that's true. However, I proved the fact that this has a maximum because the leading coefficient is negative. So I know that. But with calculus, I will do this, and p prime of x, and 500. And that's not possible. I just put infinity there, but of course it's not. So this will be 0. And when I plug in 0, for p prime, when I plug in 0, I get positive, and when I plug in 1000, I will get negative. So this is guaranteed to be a maximum. And this is really just a very simple situation.